there, 6th grade accelerated class, or should I say 7th grade on level. We are here. We have made it from what we've talked about since the beginning of the school year. We are into 7th grade curriculum officially. So congratulations on speeding your way through all of that content. Very proud of you. That being said, we're jumping in, and you don't have any book or online content anymore, which stinks. But like I said, we're not going to spend money to get you books or to give you an entire year access to the curriculum when you're only going to be using it for a month and a half. There's enough supplemental resources we can use. I'm going to send you a lot of the things from the 7th grade on level website, so you're not going to be missing too much. I'll still send you probably the extra practice before a quiz or test. But right now we're starting in chapter 3 actually, because I think that integers play such a big role in 7th grade math and continuing that it's a good place to start. Because even though we've talked about integers before, we haven't done any actually arithmetic where we're having to add, subtract, multiply, or divide with negatives. Some of y'all are like, oh, that's easy. I can do that easily. So this is going to be boring. Well, good. Hopefully I can make it a little bit entertaining for you. But we're going to blast through 2 lessons, okay? The first lesson in chapter 3 is integers and absolute value. The reason we're going to blast through this is because we actually did this already in 6th grade. They hit this first lesson as sort of a review in 7th grade, and we are going to review it in about 4 minutes, okay? Alright, so this goes back to the chapter back in the fall where we talked about how absolute zero is basically the distance a number is from 0. So the absolute value of 4 would be 4, because it is 4 units away from 0. So if you have $4, you have $4 more than 0. So the absolute value is 4. Now, the same thing works with -4's absolute value. Because where is -4 in relation to 0? -4 is 4 units away from 0. So the absolute value of -4 is 4. And I got this spiffy new board. How nice is that? Just for you guys. So just to put it in, again, a little perspective, if we had a number line, whoa, that's pretty nice, I know. And we have 0, and let's go up by 2s, 4, 6, -2, -4, -6. All obviously, as far as you move left on a number line, you're getting smaller, and as far as you're going right, you're getting larger. But if we graphed 4 on a number line, well, there you have it. And it is 4 units away from 0. 1, 2, 3, 4. Now, if we graphed -4, it is still 4 units from 0. 1, 2, 3, 4. So we say the absolute value, remember these are the absolute value walls. I feel like one of you all taught this lesson. I honestly can't remember. I feel like it was either Nicole or Maddox. I'm sorry, I don't remember, but I think one of you did. But absolute value has these absolute value bars. And then, like, if it's absolute value of a number and it's in a multi-step equation, you need to know that in PEMDAS, these are considered the same things as grouping symbols. So where we would do parentheses first, you would start by doing this. Because we need to know that we're working with the absolute value of -4. We're not actually working with -4, we're working with its absolute value, 4. So if you ever have a problem, order of operations that has this, you want to do it first, because it's in the same category as parentheses. Got it? Super duper. Let's keep moving. Alright, so that is absolute value. However far a number is from 0 is its absolute value. So what's the value of the absolute value of -16? That's right, it's 8. No, I'm just kidding. Negative 16's absolute value is 16. Good job. What's the absolute value of 400? 400. What's the absolute value of negative 39.724863297114? Well, were you not paying attention? Okay, it would be the positive version of that, because I honestly don't remember what I said. Alright, so I think you guys got that. So the next part of that is also something we've done, where we said, like, if we said that it was 52 degrees outside. Ow, that corner's sharp. If we said it was 52 degrees outside, well, how would you write that as an integer? Exactly, 52 degrees. You don't have to put a plus sign in front. It makes no sense to do that. We don't say it's plus 52 degrees. We assume that if you say it's 52 degrees, then it's positive. It's above zero. Now, if we said it is 52 degrees below zero out there, or it is negative 52 degrees, what integer would that be? That would be a negative 52. And yes, you would want to write that, because otherwise we would assume it's positive. So, how would you write a loss of 12 yards in football? A loss of 12 yards. Well, you start at wherever you started for that play, or that down, and you lost 12 yards. Minus 12. If it was a gain of 12 yards, there you go. 12 yards. Because either way, the absolute value is 12 yards away from the zero. But the integer for a loss of 12 is negative 12. Other things you might hear, and the big one we got in trouble a lot with, right, is a deposit. If we said a deposit of $50, well, that's when you put money into the bank. People sometimes think, well, I'm losing that $50 because it's not on me anymore. Well, you deposited it into your account. You made $50 from something, or someone gave you $50, and you deposited it into your account. So a deposit of $50 is this integer. You gained $50. Again, you don't need to put plus 50. We get that. All right? If it was a withdrawal, some people think, well, I'm getting money. No, you only withdraw money to spend it. No one gets it just to look at it and touch it and be like, oh, this is what it's like. Sometimes I feel like I want to do that because it's been so long since I've actually held money or had any money that sometimes I wish I could just withdraw a couple dollars and be like, that's the feel of money. But no one does that. If you're withdrawing money, you're doing it to buy something. Okay, so if it's a withdrawal of $15, then it's going to be a loss. Your account is losing that. So the integer would be negative 15. All right. I think I will send you a little bit of a homework sheet for that. It's going to be super easy, guys. I promise. One of the easiest homework sheets you've ever done. So look out for that in your email. But that's all we're going to talk about for lesson 1. All right. Actually, one more thing. We did this before, but just to make sure. If we had something like the absolute value of negative 7 minus 2, what would that equal? That's right. You did it. It's going to be 5. Because order of operations tell you to do this. Negative 7's absolute value is 7 minus 2 equals 5. So just don't forget, order of operations, to do that first. All right. My clock says that we were just doing that for about almost 9.5 minutes. So you just did your first 7th grade lesson in 9.5 minutes. Snaps for that. But now's when the real fun begins. Lesson 2, adding integers. Now, I want to write this and leave it up because I don't want you to forget that what I'm talking about is for adding and subtracting. Show wax. That was useless, you can't even see it. But adding and subtracting, these are the rules for adding and subtracting. Here's where you want to have pencil and paper ready to take notes, because you need to memorize this. Once you memorize these rules, you will add and subtract easily. Until you memorize these rules, you might make some silly mistakes and you might come up with some wrong solutions. So go ahead and get paper and pencil if you didn't already have it. I'm sure you already did because you're such good students. The rules for adding and subtracting integers. Yes, we are only adding today, but the rules apply for adding and subtracting both. The first rule, if the signs are the same, you add and keep the sign. I'll give you a moment to write that down. If the signs are the same, you add and keep the sign. Rule 2. If the signs are different, you subtract and keep the larger absolute value sign. I'll tell you an easier way to write it. It's not mathematically correct necessarily, technically, but it's going to make sense. And so it's a lot easier to say than all that mumbo jumbo I just said. If the signs are different, you subtract and keep the larger numbers sign. All right. That's it. That's the rules. And it's that simple. So, we're going to do some examples. I'll write some out, and then we're going to do what's called a fluency wheel to see how you are doing with that. Okay. Let's say I'm going to write 3 problems up here. 4 problems up here. The first one's going to be super challenging. Now, why did I put those 2 4s in parentheses, might you ask? Because you're not really going to see anyone put plus a -4 or plus -4 or anything like that. It's always going to be in parentheses. You don't have 2 signs right next to each other. Okay? You're always going to separate signs with parentheses, even if it's 2 subtraction signs, which we'll deal with next time when we do subtraction. But today is all about addition, so we have these 4 problems. Number 1, the rule still applies, although this is a simple problem. The signs are the same, are they not? We have a +3 and a +4. Now, I've told you guys before that the argument can be made that there is no such thing as subtraction, because you're always combining 2 integers. So even something like 5 minus 3, for instance, that is like combining 2 integers. It's like combining a 5 that's positive and combining a 3 that's negative. You do that, you get 2. Okay? So, again, we'll talk about that more tomorrow. But here we have 2 signs that are the same. +3, +4. So we add, according to rule number 1, we add and keep the sign. The sign being positive. We don't write the positive sign. Now in the second one, we have a -3 and a -4. Which rule will apply to this? Rule 1, still, because the signs are the same. Since they're both negative, we add them. 3 + 4 is 7. And we keep the sign. If the signs are the same, you add them and keep the sign. Simple as that. Good job. So here, we're going to use rule number 2 to solve these next 2 problems. When the signs are different, you subtract and keep the larger number sign. We have a negative and a positive. Now, you could say 3 minus 4, but let's just always keep this. You can always subtract the smaller number from the larger number. Okay? Because it's easy. 4 minus 3 is what? 1. 4 minus 3 is 1. When the signs are different, you subtract. And you keep the larger digits sign. Okay? The larger digits sign. Digit, meaning, that's why I said maybe the first time the absolute value, because 4 is going to be bigger than 3. All right, so since 4 is bigger than 3, we're going to keep its sign, it's positive. So negative 3 plus 4 is positive 1. You subtract and you keep the larger number's sign. Like I said, I say that, but if this was negative 4 and this was 3, like down here, well, this is not really larger, is it? It's negative, so it's obviously smaller than a positive. So that's why I say it's not technically correct, but we're going to use it because you guys know that 4 is bigger than 3. So here we go again. The numbers are different, so we subtract. 4 minus 3 is 1. And 4 is larger than 3, the larger absolute value of the number. You keep its sign. So 4 is greater than 3, so we're going to keep the negative. All right, you subtract and you keep the larger digit's sign. That's simple. Now, this is on video, so if you had any question about what I just said and didn't make any sense, well, then go back and watch it again. All right, and if it still doesn't, then text me and we'll figure it out. All right, let's move on to these fluency wheels. We are 20 minutes in, and I think we can get out of here in 10 minutes or less. So let's really focus. All right, the first fluency wheel. Can I get it right? Here. Cool, see? All right, so the first fluency wheel has 10 in the middle with a bunch of numbers on the outside of it. It's wanting you to add 10 to all of those integers. So when we do this, we're always going to start with the top right, okay? So that would be the one with the 8 in it. So this one's going to be super easy because 10 plus 8 is 18, and we know that. We move down to 6, negative 6. Now, the signs are different, so you subtract and you keep the sign. Again, this one's going to be super easy, but I want you to know that you're adding these integers each time. You might think this is just simple addition and subtraction. Yes, but it's really just simple addition. No subtraction. You're adding 10 and negative 6. So when the signs are different, you subtract and you keep the larger number's sign. And guess what? 10 is going to be the largest number in all of these. So you'll always keep the sign positive. All of these will be positive. Because 10 minus 6 is 4. Keep the larger number sign. You get positive 4. All right, you go ahead and pause the video now, right where it's at so we can see the image, and finish the wheel. You can either finish it by drawing the wheel, or you could just put 10 plus negative 4 equals blah blah blah, 10 plus 3 equals blah blah blah, whatever. Okay? Do that now. Why did I pause it with my nose at a profile? That is not wise for a Hawkins, let me tell you that. But did you get the right answers? Did you get 10 plus negative 4 is 6 because 10 minus 4 is 6? Did you get all of these answers correct? Good. Real easy, right? Well, this next one we're going to do is just a little bit harder, but still easy. If this one was very easy, the next one's easy. Wax. Here we go. Negative 9 in the middle. So now we're adding negative 9 to all of these numbers. Okay? So think about the first one. Remember, we start in the top right with 8. We're adding that middle value to all these numbers on the outside. So it's like saying negative 9 plus 8. Think about what you would put. Okay? Well, the signs are different, so you're going to subtract and keep the larger value sign. Well, negative 9 plus 8 would be like saying 9 minus 8 is 1. And which digit is bigger, 9 or 8? 9. So you keep its sign. So 9 minus 8 is 1. 9 is the bigger digit, so you keep it negative. Your answer is negative 1. Boom. All right. The next one, negative 9 plus negative 6. Well, still rule number 1 because the signs are the same. So you're going to add and keep the sign, and you're going to get boop. That's right. You're going to get negative 15 because 9 plus 6 is 15. Keep the negative sign, negative 15. That simple. All right, go ahead and fill in the rest of this chart. Again, you can draw it if you'd like, or you can just write out each problem. But either way, go ahead and do that now. Notice that time I didn't turn my head profile. You can see my monster bird nose. See, I learn from my mistakes. All right. What did you get? Did you get this? Well, let's talk about it. You're adding all of these when the signs are the same. So negative 9 plus negative 4, you add. You get 9 plus 4 is 13. And the signs are negative, so you keep that. Negative 13. Negative 9 plus 3, the signs are different, so you subtract. 9 minus 3 is 6. Keep the larger number sign. Negative. Negative 6. All right? Negative 9, negative 2, they're both negative, so you add to keep the sign. Negative 11. Negative 9 plus 7, you subtract and keep the sign. You get negative 2. Keep the sign of the larger value, sorry. And so on and so forth. All right. The only kind that we didn't get to in this is when your first number in these wheels, is when your first number is actually larger than your second one, the digit, Okay, so it doesn't change anything. I just want to give you an example so you can see it. If we have like negative 9, I'm sorry, we just did negative 9. If we did like 8 plus negative 11. So where your second number, is bigger than your first. Set that backwards. Well, you have a positive 8 and a negative 11, so your signs are different. You subtract and you keep the larger digit sign, larger number sign. So 11 minus 8 is 3. Keep the negative because 11 is greater than 8. All right, 11 is greater than 8, so you keep the negative. Okay, so you get negative 3. All right. Well, you don't have a book to go into, so I can't assign an independent practice. So you'll see that I sent you an assignment in your email. Again, it is a worksheet from the McGraw-Hill website. If you have any questions, reach out to me. I'm happy to help, but hopefully you learn those rules and you can apply them pretty easily. If you can, subtracting integers is going to be pretty easy for you. Well, konnichiwa, God bless. I'm so glad you could join me today, and I look forward to the next time, which will be tomorrow, in a live. So come with some questions if you have any. We'll check our homework and then we'll be ready to move on. Good job, people. Day 1 of week 2 of distance learning is in the books. Congratulations. High five.